Okay. Shall we continue? Okay, so I have some hello? No. Yeah. Hi everyone. Is it working now? No? Just make it. Hello? Yeah, here we go. Okay, so I have some remarks to make. So we realized that Bash is quite new for many of you, and in particular, I think the last exercise of assignment 2 maybe wasn't so easy as we expected. Yeah, but you know it's a useful script after all. You can hopefully use it. But so for this reason, it's really no problem if you need an extension. Just I can give you a 3-day extension if you send me an email. Yeah, and then you have the chance to still submit it in time. And so also feel free to come to the group session today, and I think there's one tomorrow as well, and just ask about Bash and how this works. Also, remember that the group sessions are quite flexible. So just because you're in group number 5, you're free to move to go to another group session. It's not a problem as long as the groups aren't becoming too big, as long as certain groups aren't becoming too big, right? So it's really, we're trying to be as flexible as possible, and so just go to the group sessions that are most convenient for you. Then please sign up to Piazza if you haven't done yet. So there's a lot of information that I post out there, for example, the video lectures or announcement about the assignments. And in fact, many tips and tricks about how you can solve the assignments are being discussed on Piazza. So it's a really useful resource. So I can only recommend to sign up if you haven't done it yet. And finally, some students asked me about if it's okay if they have Python 3.4 or 3.3, and the answer is yes, it should work. So for this course, at least as far as I know, any Python 3 version should work just fine. So you don't need to have exactly the same version as I do. Yeah, and also the next assignment I don't think will be will hopefully be not so difficult as assignment 2, the last exercise of assignment 2, I was told. Okay, are there any other questions regarding assignments and deadlines and so on? Everyone happy? Yeah?
When do you get feedback on your score?
Yeah, so the question was, when do we get feedback? So the assignment 1, I think, is finished very soon, and I discussed it this morning. We're trying to finish assignment 2 by the end of this year. But yeah, exactly. Oh, where? So I'm at the end of this week, and it's going to be on Devlery. Okay. So, yeah, let's continue. So I told you about this range statement. Yeah, I might mention something about these IPython notebooks later, but let's continue for now. So I told you about this range statement that allows us to loop over indices, and the obvious thing where you can use this is to use it to index the items in a list. So here I have a list with the items hello, Sam. And then I loop over the length I loop over all the integers of this, of all the indices that I have in this list, print out the index, and then access the item at that index and print it out also. So then I also always get index, and then the item in the list, the second index, the second item in the list, the third index, and the third item in the list. Right, so that's an easy way how you can loop over lists. This is an easy way how you can loop over lists and at the same time also have access to the index, right? We already know how we can loop over lists without needing the index, because then we can just write for item in list or for item in my list. But if you also want to have the index, then this is one way of doing it. But there's a more Pythonic version of doing it, Pythonic meaning a prettier version of doing it, and that is by using the so-called enumerate keyword. And the way it works is that the enumerate takes in a list and returns tuples, a list with tuples, always containing the index of the item and the value of the item for each list. So with enumerate, what I can do is enumerate returns a list, so I can just use the standard for item in list notation. But now item is actually a tuple, so I break it up immediately into the index and the value of each item. And so then in the loop, I have access to both the index and the element, and I can print it out the same way. So compared to the implementation above here, I've saved, well, I actually haven't saved that much, but it looks a lot prettier. Yeah? So I get access to this element immediately. I don't have to kind of use this index notation up here. So here's an example on how we can combine these loops and the branches. So we have two floating points number here, an integer and floating point, and then we loop while x is smaller than 6, and then we check if x is smaller than 2, then we add dx to it. Otherwise, if x is between 0 and 4, so note that we can use these combined. We cannot only have one comparison in one line, but we can actually check if x is bigger or equal than 2 or smaller than 4. So in this case, we add 2 times dx, and otherwise we add 3 times dx, and then we always print this new x. And we continue this loop until the condition up here is false. In which case you jump out of the loop and we print out loop is over. And so if we run this, we will get new x 1, 2, 4, 7, and then we will check that, and then the loop is going to be finished. So again, note that I use these 4 spaces always to denote which lines are part of a while statement or if statement. So basically everything that's intended here, all these lines here are part of the while loop, and this line here is part of the if loop. So sometimes it's quite useful if you can stop a loop in the middle, or in the middle of a statement, or if you can continue a loop without calling all the statements in the loop. So here's an example where we can jump out of a loop, and it's done using this break keyword. So imagine we loop through all the characters in a string, here hello, and then we check if the character that we're currently looping over takes the value L, and in this case we call this break keyword, and what that does, it will jump out of the loop. So we won't actually continue the loop for all the characters, we will stop here immediately. And so the output will be that we execute the loop for the letter H, and then we execute it for the letter E, but after that we hit a character L and we stop the loop. So that's done. So that's how you can stop loops early. You can also use the continue keyword to jump back to the loop, to continue to the next item in the loop immediately. So basically have exactly the same implementation as above, just with the continue statement instead of the break statement. And the continue statement now doesn't stop the execution of the loop, but rather continues with the next character straight away. Which means in this implementation means that we're not executing the sprint statement for all the characters that take L. Which means that the output will now be HEO, because we're missing out all the L's. Okay? So break and continue are quite useful if you have more complex loops. So the next one is called list comprehensions. And that's, again, a very Pythonic way that allows you to make the program look a lot, it makes the program often a lot more readable than if you have a standard C implementation. So imagine you wanted to loop over a list, and you wanted to loop over one list and update another list. And in C, or a C-style implementation, what you would do is you would loop over all the indices of the first list. So you use this range length of A statement to loop over all the indices of the length of A. And then you would use this update statement here where you assign the ith item of B a new value based on the ith item of A. So that's a that's a C version, and this will also work in Python. But in Python, we can also implement it this way. So what we do is we start with a empty B list, and we loop over all the elements in A, and we just append new items to B using the b.append statement. And we always append this square root of the element of A. So this does exactly the same thing as above, but now we went down to 3 lines instead of 4, and we got rid of this indexing statement, which makes it often harder to read. We can even reduce this to 2 lines now by using the so-called list comprehension. And the way this works now is that we combine these 3 lines in a single line by writing B equals square bracket, element squared for each element in A. This is a list comprehension, and what it will do, it will loop over all the elements in A, assign them the value element, and then create a new list that contains the elements squared. So B, the list B, has exactly the same length as A, with all the values of A squared. So 3 implementations, all doing the same thing, the last one being the most Pythonic version, the second version to be also quite Pythonic, but the first one being kind of the traditional C implementation. Okay, so that's all I wanted to say about control structures. Next, we move on to functions and arguments in Python. So in Python, we can define our own functions. And here's an example of a user-defined function. And so for everyone who is not familiar with functions, so functions is basically a recipe of commands that you want to execute. And a function can take in some arguments, and it performs some calculations on the arguments, and it returns a value. And then you can call this function with different arguments and get their return value out. So instead of, this is often used to avoid duplicating code. You can, instead of just copying and pasting the code over and over again in your implementation, you can just write one function and call that function with different inputs. And the way you define a function is with this def keyword. So def indicates that a new function starts, then you have a function name and some parameters, and colon indicating that now the function implementation starts. And again, you're indenting all the lines that are part of the function implementation, and use this return statement to indicate that the function, that this, whatever is on the right-hand side of the return statement will be returned by the function. So the way we can call this function is by using, so you in this line down here, you're calling the function split, and you use normal brackets to pass in the arguments that the function takes. So here we have a string argument and a character argument, and we are now calling the split function with the message string and the I string. And we store the result in a variable called result and print it out. And in our case, what the split function does is it splits the string at the given character. So our original message was hi sun, and the return will be a tuple with the first item being hi and the second sun. So here's the general syntax of a function. As I mentioned, you always have this def keyword at the beginning, then you have the function name, and then in brackets you have all the arguments that the function takes. Note at the end there's a bracket and a colon missing here. But yeah, you can have as many functions as you want. You can also, for some of the arguments, you can specify default values. And you just do that by equal and then passing the value of the default value that it should take. The next line here is a so-called doc string, and I will talk about this in a second. But this is basically a string that documents what this function is doing. And then you can have a block of statements, as we've seen before, and at the end a return statement that returns the value of the function. Then we can call functions. So there are different ways how we can call functions. We can just type in the function name and then give values for all the parameters that the function takes. And this is actually equivalent to also specifying the name of the argument. So because the first argument is called arg1, I can also type in arg1 equals 1.0, arg2 equals x, and so this should be in arg3, arg3 equals I. The advantage of doing it the second way is you can then, in the second way, the order actually doesn't matter. So you could first specify arg3 and then arg1 and arg2, and Python will know that arg3 is here, so it will actually match it up for you. So if you specify the name of the arguments here, then the order doesn't matter. While if you use the notation up here, then you need to make sure that the order of the arguments matches with the order in the function definition up here. So for default arguments, so the ones in this case arg2 and arg3, you can actually leave the arguments out. So in the example down here, we have a value for arg1 and for arg3, but we don't specify an argument for arg2. We don't specify a value for arg2. And so for this function call, Python will just assign the default value for arg2. Okay? And so finally, if you have partially keyword arguments and partially non-keyword arguments, then you need to make sure that you always have the non-keyword arguments at the beginning. So here, the x, I didn't specify the keyword, so that's invalid, because before that, I have a keyword argument. So yeah, in this case, I would need to swap these to make it a valid function call. Let me just go back. I just wanted to give you an interesting property of functions that is often used. So in C, on many programming languages, functions can only return a single thing, one object, one integer, one float. And that's also true for Python. So Python can always only return a single item, a single object. But what is often used is that you actually simply return a tuple of objects in Python. So imagine you wanted to return an integer and a float. You can't do that, but you can put the integer and the float in a tuple and just return the tuple of the two. And that's, for example, what's being done here. So here, this return statement reads return string, comma, to empty in an empty string. And so remember that we can create tuples by just leaving out the brackets. That's what's going on here. So implicitly, actually, you could also, this is equivalent to just adding a round bracket before the string and after the two colons here, quotation marks here. So effectively what you're doing here is you're returning a tuple with the first item being a string and the second item being an empty string. And then, then you get this as an output, and you could access the two parts of that tuple afterwards. So this is just a very common way to return multiple objects in Python, which is really just returning a single tuple containing these objects. Okay, so here's something really important. It's called documentation, and it's something that you should always do when you write your script. You should do it because you might share it with other people, but you should also do it because you might actually need to change that script a year later, and 1 year later, if you haven't documented your script, it will be very difficult to understand what's going on, in particular if it's a bit more complex implementation. So luckily, Python gives us a standard way on how we should document our scripts. And that's for functions, that's always the first line after the function name definition. So here, I create a new function, and immediately afterwards, I have, in this case, it's a multi-line string that describes my function. And so I explain what the function does. I also explain which arguments it takes. So the first argument is an integer. The second argument is a string. And I explain what they're for. And I also explain what this function returns. So this is really, really good coding habit to always document your functions this way. And so what are these docs? So remember, that's always the first line after function definition. So these are called doc strings, and they're used in various ways. So for example, they're used to document your source code, so you can just read it and you can see the documentation straight away. There's actually programs that can automatically extract these doc strings and make a nice web page out of your program with how to use your library, for example. Sometimes you can get some kind of balloon helps and sophisticated graphical user interfaces. It can also be used to do automatic testing. And you can also use it for interactive documentation in IPython. And so I'm actually here on an IPython shell, and I can show this to you. So this function with types and docstring is the function that I've created before. And if I type in a question mark after this, then it doesn't work. There we go. So then it will automatically open up a little window for me, and it shows me the docstring that I've written down before. Right? So so here it tells me the signature and the docstring and where this file lives and so on. Okay. So that was all about functions. So now I want to tell you two more things about two other statements in Python that you can use. They're called eval and exec, and they basically turn strings into live code. And so the reason why I show them is many people actually state that you should avoid them. But the reason I want to show them to you is because they kind of differentiate classical compiled languages to scripting languages. So this is something that would be quite difficult to do in compiled languages, but it's very easy to do in Python. So what eval does is it takes in a string and it just evaluates the string as if it was normal code. So in this case here, we have x equals 10. We have a variable x with the value 20. And then we call this eval, and eval takes in a string and it reads x plus 1.1. And so effectively what this does is you can just think of removing the eval and the bracket and the quotation marks, and just read it as r equals x plus 1.1. And that's what's happening. And so the value of r will be 21.1. And the type of r will just be a float. So what you could do here is you could ask the user to input an expression. Then you get this expression as a string, and you could evaluate it in your program using this eval function. So just some notes. So eval always takes an expression, and it returns the evaluation of that expression. So you can use eval on the right-hand side because it returns something, you can you can create a variable with the return value of eval. Eval, another thing to note is that eval only works on single expressions. So you can't pass in the string of a function definition in here, for example. This won't work. You also can't have multiple expressions in here. So basically, you can only have things in the string here that would also be valid if you just type them on the right-hand side of an assignment. The other thing is exec. So exec works almost like eval. So exec also takes in a string and executes that string, and it executes it in this. For exec, it executes it almost the way as if it was code in your script. So again, for exec, you could just think of removing the exec statement, removing the string statements, and just insert the content of the string into your code. And of course, you have the additional flexibility that you could do some replacement in the strings before you executed it. So yeah, so basically exec allows you to inject additional code into your program and based on a string. And this string could be read in from a file or provided by the user. So one thing to note here is that exec doesn't work as a return. So exec returns any kind of return value. It always returns none. So if you typed in a equals exec here, and you tried out to print a, then you just get none. You will never get something. You will never get a return value. But so in this case here, we actually dynamically create a new function in our code, and then we can call that function just as if we had defined it in a normal way. Okay, let's talk about how we can read and write files in Python. It's relatively straightforward. So if we want to read files, we first need to open the file. We use this open keyword. We provide the file name, and we provide this additional character here, R, indicating that we want to read, that we intend to read from that file. And then this in file is just a normal iterator, and we can use the standard for element in list syntax to loop over all the lines in that file. So if you printed out line here, then you would get the entire line printed out to screen. Alternatively, you can read in all the lines of that file using the .readLines function, and that will return you, that will read the entire line in one go and return you a list of strings with each element in that string is one line in your file. Finally, you could also use standard index notations. So you loop over the length of the lines and then use the lines square brackets I to access a certain line of that file. So this is often useful if you need to access one line and the next line at the same time, because then you can write lines I and lines I plus 1 and compare them, for example. So finally, you can use the .read function to read in the entire file as one big string. So remember, the read lines gave you a list of strings with each element being one line as a string, while .read just really gives you one massive string with the entire content of the file. And then you can, for example, replace some items in this string and split it and so on. And after you've done with reading, then you should always call infile.close, which will close the file and make it accessible for other programs again, so that you don't end up. So for reading, it's actually not that important, but in particular, if you're writing, then you always need to make sure that you're closing your file so that not multiple programs end up writing to the same file. So that comes me to my next topic, writing to files. It works very similar to reading. So again, we use the open keyword. We provide the file name. And now we use the W character in case we want to create a new file. Or we use the A character in case we want to append content to a file. The result will be, again, a file object that we can use to access the file. And we can use the write function to write content to a file. So write just takes a single string. We can also use write lines, which takes a list of strings to write multiple lines at the same time. And when you're done with writing, as I mentioned, you make sure that you always use the file object.close to make sure that you're closing the file and basically write everything, write the entire buffer that to disk. Okay, and that comes me to my last topic, modules and packages. So modules are basically, it's a strategy in Python that allows you to organize your program in a more logical manner. And a Python module is nothing else but just a normal file that contains Python code. And so a module can define functions, classes, and variables. But it can also contain normal runnable code. And so why would you want to use Python modules? So first of all, you can split your code into multiple files, which makes it easier to maintain. You can also group related code into one module and maybe share it with other people so that they can use the same functions in that module. Or you can even publish that module on the web, make it accessible for other people to use. So Python, by default, already comes with loads of modules, and we've been using some of them already. So for example, if you want to use a module, use this import keyword. And so for example, in this case here, we import the sys module, and the sys module has an argv variable, and that's a list. It's a list of all the keyword arguments that is passed into the program. So here we import the module sys, and we access the argv variable that is part of the sys module. We can also, instead of importing the entire module, we can also import just one variable or just one function in that module. And we do that by using this syntax from sys import argv. And now, after that, we can just write argv instead of sys.argv. So here we've imported a single variable from a module. We can also import directly all the variables in a module. So here, remember we just imported argv. With a star, we import everything that is contained in the variable, in the module. And again, then this argv will be part of it, so the next line will be valid. But this is actually not a recommended way of doing, because you might import a lot of variables that you might not be aware of. So for example, sys also contains a flex variable. And later on in your program, you might not be aware of, but if you create a new variable, flex equals empty string, you're actually also overwriting the flex variable in the sys module. So you have to be very careful if you're using this from module import star syntax. It's often much better to be explicit about the variables that you're importing. Finally, there's a syntax how you can import a module under an alias. So you can import the argv variable, but you want to have it accessed as under the name A. So then you can just use A here. Okay, so if you want to make your own module, it's actually really simple. So as I mentioned, you just create your own file, just a normal .py file, and you put all your files and functions that you want to have be part of that module into that file. And then you put this Python file into one of the directories where Python can find it. I'll show this in the next slide. And once you have done this, what you can do is you can write import mymod, where mymod was the file name without the .py. And if in your mymod, if you have a variable m, then you can also write import mymod as, oh sorry, this syntax here just gives the module another name. But you can obviously use this star syntax, so from mymod import star to get all the variables in your module. Or you can import just some functions that you have implemented in your module. And again, for modules, it's the same thing as for functions. The first line in the module file is a doc string, and it's really recommended to document what your module does. So how does Python know where to look for modules? And so basically, there's some standard paths that Python looks for. These are written here. And also the current working directory. And in addition to that, there's this bash environment variable Python path that tells Python about additional paths that it should look for. And if you want to have your own path where we install your module, we can actually expand this Python path and add our additional module so that Python will find our modules. And this is how we can do this in the code. So for example, let's say we have our module stored in the directory, in the home directory /python/lib. What we can do is we can import the sys and the OS modules and extend the search path of Python by the path where we store all our libraries. And once we have that, then we can import our my module, and Python will actually find it. Okay, so then we also have packages. So a package is basically just a collection of modules. So it's one hierarchy up. And they are simply organized as a directory tree. So you just put all your modules that you have in one directory. And in addition, you add an __init__.py file into that directory. And if you've done that, then you have a package. And if you want to learn more about package, you can look up the section 6 in the Python tutorial. So here's an example of a package. So imagine this is a directory tree. Unfortunately, these underscores are missing out. But basically, this is a directory tree with a main directory mymod. In mymod, I have a file ._init__py. In there, I have also folder numerics. So that's a package in a package. Again, I have this __init__py. In there, I have another package called PDE. Again, I created an __init__py. And now I have a module in there called grids.py. And so now what I can do is, if this is in my Python path, what I can do is I can write from mymod.numerics, which is this file, path here, .pde, which is this path, .grids, which is this module, import fdmgrids, which is maybe a function or a variable that is contained in this grids.py variable. So now I imported this function or variable, or in fact it's a function, and then I can call it down here. So this is how we can really structure many quite large projects into directories and modules. For modules, it's often quite useful to have some code that is normally not run if you import it, but if you call the module with python.modulename.py, then you might want to execute that code. So maybe for testing, if you call the module as a script, then this testing code should be executed. But if you import that module, then it should not be executed. And you can do this with this magic if _ name _ equals this _ main string. So everything that will be part of that if statement will only be executed if you run the module as a Python script, but not if you import that module. Yeah, and so these tests that you write down here, they're often very nice. They're often being used to show how the module can be used. So modules can also have, by default, all the variables that you have in a module are public, so that you can access them. But there's a convention, if you create variables or function names that have an underscore in front, then they're somewhat hidden. They're still accessible, but they're not visible by default. So for example, if I then type in from my mod import star, the underscore counter variable is not available because it's got this underscore in front. Again, the same way the underscore file name is not accessible. But if I use the import mymod or mymod and then mymod.counter, then I can even access these non-public variables. So with this syntax, I always get access to all variables. The same way I can actually call non-public functions. Okay, so how do we install these modules? So we've created them, and maybe we give them to someone else, and someone else wants to use your module. And the way this works is that Python comes with its own tool called distutils for distributing and installing these modules. There's an alternative, which is supposed to be more modern, called setup tools, but for this course, we actually use distutils. And basically, when you want to install a module, you have this setup.py file, and you can call sudo python setup.py install, and that will then install your package and make it accessible, install it in the directories that are accessible to Python. You can also specify, by using this -- prefix options, you can specify where the module should be installed. Yeah, I'll just jump over this. I just want to show you how you can write your own setup.py file. So this is if you now created your module or your package with all the directives in there, and you want to make this package installable using the setup.py function. What you do is you create a new file, setup.py, and you add the contents down here. So you add this from distutils, core import setup, you give your module your name, and then you call the setup function with a name and a version, and you specify all the modules that should be installed, and also all the scripts that should be installed. So scripts are scripts that can be executed, while py.modules are names of modules that can be imported. Yeah. And that was it. So basically what I wanted to show here is that just if we go back to our original directory tree of our package that we've created here, if I have such a directory tree and I add a setup.py up here with the content shown below, then I created a package that makes that I can hand out, that I can zip, hand out to someone else, and then another person can install it using the setup.py routine. Okay, that was it for now. Thanks.